Ready to go?
Yeah, ready to go?
All right.
Okay, let's go.
Cool. Thanks for bearing with us while we figured out how to do things. Really set up a great Microsoft joke, but since they were so nice to lend us their building, I'm not going to. I'm gonna take the high road. Thank you for coming to my talk. You've got to enjoy my awesome splash screen, and I'm glad I put some time into that. How do I advance slides now? Cool. Just when I thought we were, there we go. Legal disclaimer. I did not make The Legend of Zelda. I was 2 years old when it came out. This is covered by Fair Use, Copyright Act, blah, blah, blah. If anybody wants me to take this down, contact me and I will happily comply. My name is Trevor Grant. I am a PMC of Apache Mahout, a co-lead of the GoFandon project, which I'll be talking about with you today. I got this new email address. I don't check it very often, but you can send me emails there. I have 2 boys. There they are, maxing on pizza, watching TV. I wrote an O'Reilly book on Kubeflow and a few papers about this and that. Car free since 23, actually 22, but that doesn't rhyme and roll off the tongue so easy. And a special thank you to IBM and the AI Alliance, the patron of my artistic endeavors. About the AI Alliance. Founded a couple of years ago, we building the future of OpenAI in an open sort of way. Unlike OpenAI that is not even trying to be in name only anymore, we are actually a community of a lot of industry partners, Fortune 50 companies, Fortune 5 companies, I think, big companies and small startups alike. GoFandon is a part of that, and that's a big deal because the AI Alliance is not quite a code foundation, or they're kind of trying to be one. They're still growing and figuring it out, but there is a system of governance there. And if you know much about contributing to open source projects, that's a big deal. And community. So unlike, we call it the despotic, the benevolent despot of open source projects, we don't have that problem. Shameless plug, I'm also the lead of the Agents Working Group. If you're here, you may be into agents. Please check us out. We are still standing up. We are kind of falling into 2 main categories, research and practical applications, so please join us. In this talk, we will talk about agents, tools, and functions, or the Triforce, to abuse the Zelda analogy. We will talk about GoFandon, which is a repository of tools, and how it, losing the word, the write once, run anywhere principle that is core to GoFandon, as well as GoFandon's other features, including one of its primary missions to help open source contributors make their first commits to open source, and how we go about that. And time permitting, we're going to do a little demo that I cooked up this afternoon. So the Triforce, Zelda style, agents, tools, and functions. This is not a useful diagram other than leaning into my Zelda. This is a more useful diagram. We've got agents, which an agentic framework has a lot of things, but at a minimum core, it will have LLMs and tools. LLMs are a whole thing. This talks about the tools. Any tool will consist of a function, like some code to do something, and descriptions which let the LLM understand what that function does. It's like the docs of the function that the LLM reads. So for functions, basic computer science, you have retrievers, actuators, and calculators. Any kind of computers, any function of code anywhere, never mind this context, a function does one of 3 things, broadly speaking. The descriptions, OpenAI has a very, very popular SDK. Every LLM has its own kind of way that it likes you to do the descriptions for the functions. Every agentic framework has its own special way that it wants you to do your descriptions, but it's all basically the same thing. It comes down to docs for the function. But tools are the real stars of the agentic show, which is I think I used Dolly on that one. Little Muppets. I was pretty proud of it. Any rate, tools are the real stars of the agentic show. What the tools do are what make it seem like agents are doing all this cool stuff. Because really all an agent is several LLM calls and some tools to give it these extra powers. And again, your retrievers, if you need a little more explanation here, retrievers get your information, an actuator can go out in the world and do something, and a calculator that can just perform a calculation. And then the descriptions, again, are the documentation for the LLM. which leads me into GoFanon, which is a repository of tools. And that's all we're trying to be. And it's kind of difficult to maintain that discipline and not become an agentic framework. We've had to, a few times, steer ourselves back in and say, you know, that's more agentic frameworks. We're just the tool repository. Tools that we're currently supported, we've got GitHub, some reasoning tools, headless web browser, NHST, that's the highway traffic safety. I think I mixed up some of the letters there. Google search, Open Notify Space, because that's what the Bedrock example used, Archive, basic math. But we also, and this is really our more cool thing, is the inter-framework compatibility. We currently support small agents, LangChain, and Bedrock, and I think, and GitHub. GitHub's not really an agentic framework, but what it does do is allows us to use our tools in some other non-agentic ways. We have a PR reviewer tool that if you've ever reviewed PRs, is kind of a pain. So it just runs it through an LLM real quick and gives you the overview, and so you can, it speeds up PR reviews. Write once, run anywhere. I said I was a PMC on the Apache Mahout project. Apache Mahout has the write once, run anywhere is definitely part of the DNA of the project. These guys are laughing because I always drag Mahout into a talk. Write once, run anywhere. If you've ever had to port code from an old system to a new system, you will appreciate why this is an important thing to do. And anecdotally, for the agentic case, real quick show of hands, I'm kind of talking at you and assuming I know what you guys are all about, but how many people are familiar with what agents are? Played with them some? And okay, all right, cool. So imagine two hypothetical agent frameworks. Framework A, easy to set up, run it on your laptop, you can play around, doesn't really scale well, you can't take it to production, but you can make cool toys on your laptop. Framework B, scales production, awesome, super difficult though to very steep learning curve, just getting to hello world is an exercise in misery. So which do you start with? You start with the production grade framework and maybe never even get your idea off the ground, or make a really cool idea and then live in pain and misery trying to scale it out to something productive grade. Write once, run anywhere, you write it on your simple framework and then you just port it over really quickly because that's how the whole thing is supposed to be. So GoFanon's features, again, cross-framework compatibility, standardizing, being able to take a tool from small agents, because small agents' big thing is using Hugging Face Hub, and you can use tools from here, there, whatever. And you can use that you can port that tool with 2 lines of code into LangChain, or into Bedrock, or into, as we keep adding more frameworks. That is a core feature of GoFanon, and why we kind of started the project to begin with. And then open source education, our other big pillar, curated contribution pathways, noob-friendly PR reviews. How many people are maintainers on open source projects? No one. How many people have contributed to open source projects? All right. Did you get the feeling that maybe you were trying to contribute and people were just really exasperated, having to hold your hand through everything that was going on? Because they all had their weird little rules and special thises and that's. And okay, so we understand that and we are explicitly saying, cool, we will hold your hand. On the Mahout project, I don't know why, I just got 30 college kids from India who all want to contribute. And that's great, we need more contributors, but my day job is not holding the hand of people trying to make their first contribution to an open source project, except what it is, come on down to GoFanon and I'll teach you how to contribute to open source projects. Then you can go back to Mahout and do some stuff. We also do weekly office hours. Again, it's just a very open for business kind of community. And going further on that, people who have contributed, usually your first contribution is something simple like fixing a spelling error in docs, or some really kind of trivial okay, cool, it's my first contribution, I'm trying, you're really just learning the ropes of going through what does the PR process look like. We have, an idea of this was, look, there are an infinite number of functions you can have. There's really almost no scope on that. So whatever function you want to write, you can write it. And now you are, instead of making what are the good first contribution issues, you are learning from soup to nuts how to scope out your own feature add, because this was something I noticed a lot on Mahout too. Nobody wants to make their first contribution an easy little thing. They want to make some huge feature dump. I'm like, I don't want your big feature dump, man. But on this project, we do. You want to look up NASCAR results or who won the wrestling world, the WWE Royal Rumble last year. You've got some API to do that. Cool, man, make a feature. Somebody's agent somewhere will need to know that information, and then they can just pull your function or your tool off the shelf. Great. But you also learn that the feature is really only about 40% of the contribution. It is also testing and documentation and all that other boring stuff that you really don't want to do. And that is also a big part of learning to make contributions to open source projects. Because I don't want to maintain your Royal Rumble function. I want it to be pretty much on autopilot, so it's okay. So I wrote a abstract for Berlin Buzzwords, and I made this the title, and I'm curating this deck to eventually make this slide make sense in this deck. I'm still a little ways away, but there we go. So now we will go to a quick demo of this whole thing in action. I'm going to use this one. Am I still on? Okay. I don't know how to full screen. Okay, well, there we go. All right, so install dependencies, pip install, easy peasy. How many people played with small agents? Or at least looked at the GitHub README? The GitHub README, they look at DuckDuckGo search, I think. We are going to basically follow that with a couple of changes. Instead of using the Hugging Face API for a model, we're just gonna hit OpenAI. And instead of, I cannot.
I'm sorry.
Yes.
I think I'm like a lot of people here where things are happening very fast in the AI space.
Sure.
I'm still getting my sea legs. I think before seeing the demo, it would be really helpful to me if you told me a little bit more about yourself and kind of your arc over the past 2 to 4 years that brought you into AI and how you got into tools, because I think that would help me understand more about this world, what you're talking about with some of these things. And if that's not good for anybody else, I completely understand. But I think understanding where you were, how you got here, what you learned along the way would help me understand this stuff.
Absolutely. I will first defer to our master of ceremonies. Can I go over the 20 minutes?
Yes, sure.
Okay.
Absolutely.
All right. Given that I can go.
And if anyone has attended these AI camps with me, I never stop anyone.
Okay. So then the question was, could I do a quick narrative of how I ended up in AI and open source and et cetera, et cetera. It wasn't the last 4 years. In grad school, I did grad school in applied math, and I had two really cool grad advisors who were both getting into machine learning, I think they were calling it back then, and I think it might have been before machine learning. It's like 2012. So I had a couple of professors. I was writing in R. They all loved me because I wasn't great at math, but I was really good at programming. Because self-taught back in I think in 7th grade, we had to do like a how-to talk, and I got a book from the library on old MS-DOS basic, and I wrote a video game. It was really cool. Anywho, so I knew how to program, so the math professors loved me. And I used that to go to my first job. They thought they needed this whole thing. I wrote an R script to do it the first week I was there. They're like, that's cool. They were marketing companies. The way marketing companies work is they paid me X, and then they charged the client 3X. So my boss is like, that's awesome you did that. This job that we thought was gonna be your full time, you now have a script that takes an hour a quarter to do. Cool, just go do other cool stuff so we can keep charging the client for you. I'm like, okay. So I just learned Python, and I just started kind of playing with this and that, whatever else. Way led on to way. I ended up at ApacheCon in 2016, having beers with somebody, and that's what got me on the Mahout project. Mahout was the original machine learning on big data, because these guys are laughing about my Mahout callbacks. If you're not familiar with Apache Mahout came out in 2010, but it hit its zenith right before Spark. Sean Owen left the project to go start Spark ML because he got in a pissing match with somebody else. I need to be careful how much gossip I'm talking about because this is broadcast. At any rate, so that was my machine learning entry. I was also doing some I started doing machine learning stuff for the AI or the marketing client too, because those were easy wins that the marketing people like, ooh, ah. I'm like, no, you're looking at the wrong part. But at any rate, it worked. So I started playing with transformers in 2015. Before the deep learning that we have now, there were LSTMs, and before that, there were recurrent neural networks. And it was neural machine translation that Google dropped, I think, in 2015. And I took like the last, I think, 100 words of a Star Trek script to generate the next 15. So I could just like watch new Star Trek content all day long. It was babbling nonsense. I've got online artifacts about it. I'm gonna give a great talk about that someday, but neither here nor there. So that's how I got into doing all this deep learning stuff. Wrote a blog post about it I wrote that Kubeflow book. That's all machine learning stuff. I was doing a lot of talks. So I've just been kind of in the space playing, really. And when I said IBM sponsoring my artistic endeavor, patronizing my artistic endeavors, it's pretty much what's been going on since about 2016. I go and play, I do cool stuff, and then they just keep paying me to do cool stuff, and it usually kind of works out for their interest too, is the gist of it. I met Dean and Mike in that time as well. Good narrative? Okay. So I guess that would be the advice for anybody starting out. Just play and do things that seem interesting to you. Don't be worrying about making money. And if you're enjoying what you're doing, it's not like you're really working. So this font is really small and difficult to see. So I'll just give you the high level of what's going on here. We load a model, which is just an OpenAI model. We use this line. Now we're hitting Google search. And down here, we run the agent. I think it's, how many seconds would it take for a leopard at full speed to run through Pont d'Arc? I'm not even saying that right. And it kind of goes and it thinks and it looks things up on Google and it goes along, and final answer 9.3 seconds, which I don't know, I ran it on small agents the way they said to do it too, and it also came up with the same answer, so I'm convinced that it is correct. A more contemporary example, when did the MacBook Air M4 release? A fact that was well after the GPT-4o cutoff date, because I think GPT-4o maybe could have done that by itself. When did the MacBook Air M4 release? Well past the GPT-4o cutoff date, and it still got that right at March 5th of this year. So it is doing things. But again, that was pulling a function in that it's just showing the integration between small agents and GoFannon. That's the ta-da there. So with that, I will open up for questions. I may be over, but nobody seems to be cutting me off.
What is the benefit of using GoFannon with small agents rather than just using small agents?
So the question is, what is the benefit to using GoFannon with small agents as opposed to using small agents on its own? The idea would be is, let's say I wanted to scale this agent out to a production grade system. This isn't a great demo for that. We're going to be working on a better demo, because it also has integration points with AWS Bedrock by the Botto 3 interface, CDK coming soon. It's about 4 more lines of code to deploy this to a production grade system. Botto 3 is non-trivial to learn how to work with, unless you already know Amazon and all the Botto 3 stuff, but not everybody does. So 3 more lines of code, boom, you're in production.
Would you call it somewhat like an adapter for tools then?
It is, yes, that is a great way to think of it. It's an adapter for tools, but then also with that onboarding for people who want to make their first commits to open source. The question was, would you call it an adapter for tools? Mm-hmm.
Yeah, so
Sorry.
it provides a library that anyone can use to create these agents. What does it actually provide?
So you're bringing your own agent library, be that small agents, LangChain, Bedrock, or the 3 that we're currently on. We are providing a series of functions in that interconnectivity layer so that you can pull something from small agents, put it in Botto 3. Pull something from LangChain, use it in small agents. It's a Rosetta Stone or a shim, if you will, between various agentic tool layers. Provides connections. Java bindings are coming soon. You are welcome to use ChatGPT and write whatever Pascal or Fortran bindings you want. COBOL? Yes.
LangChain versus small agents, is that something that
The question was, would you use LangChain versus small agents, would you use one versus the other for different cases? I don't know that I would. I mean, I think all right, so this is me shooting from the hip. LangChain was like kind of the first one, and so it set a lot of standards. And then you have like small agents and you had a lot of other things that came after that, and they always so LangChain was a big one just because it was first, whereas small agents, now everybody since then positions themselves, all the agentic frameworks, let's call LangChain like maybe Gen 0, and all the Gen 1 agentic frameworks that we're in now all position themselves against LangChain, in my experience. LangChain is very verbose and takes a lot of boilerplate code, and it's painful to set up. It's like using an iPhone 3. I mean, you can still make calls on it, the apps aren't great.
Plans for integration with Llama Index?
Are there any, the question is there any plans for integration with Llama Index? Yes, do you work for Llama Index? No. Oh, anybody who wants, so we are reaching out to a number of agentic framework providers and going through and be like, hey, here's our project. We would love for you to contribute bindings. It's a chicken and egg problem. You kind of got to get a little bit of size and some stars. Oh, by the way, everyone make sure to star the repo. Yeah. I think, I don't know, you get internet points for it. I'm not sure. But we want to get a certain mass, and then we'll start reaching out to agentic frameworks, be like, hey, you want to contribute some help. Salesforce and ServiceNow especially are very active in the AI Alliance, and so we're going to be talking to them soon and hopefully getting the ServiceNow agents. That's another production grade, steep learning curve one. But again, so if the data scientists can, LangChain's, so whereas ServiceNow is probably more of a production grade one, I would think of Llama Index as more of a, I did this on my laptop layer. But roadmap, yes, finding someone from Llama Index, or at least reaching out to Llama Index would be the first probably step. Other questions? All right, well, my voice sounds like it's getting ready to go anyway, so I will let it stop there. Thank you very much.
How about now? There we go. Okay, thanks for bearing with us. All right. My name is Joe Olson. I also work for IBM Research along with Trevor and Dean. I'm also part of the AI Alliance. I'm one of the IBM research representatives on the AI Alliance. What I'm going to talk about here is I'm going to continue Trevor's talk, but what we're going to do is we're going to take one of the functions that's actually in GoFannon that I wrote as part of the contribution process to test out a contribution to this. And we're going to deploy it on the AWS Bedrock framework. So you can actually see this thing go from function, and I'll step through pretty clearly how we do this, how to go from a function that's in GoFannon up into a living, breathing agent that you can then distribute. But before I start that, I just want to go through the character arc here. The reason I'm here right now is because of meetups, okay? The pre-COVID meetup scene in Chicago was pretty good, and that's how I think I know everyone that I'm working with here, is met them through meetups. And it's when you start going to meetups and you meet people who are ahead of you on something you want to learn, you are motivated to learn. You sit in the audience and you say, oh God, I'm so far behind, I have to learn this stuff, because if I don't, I'm going to be left in the dust. So the meetup scene pretty much shut down when COVID hit. Now it's starting to get going again. So I just want to plug this whole idea of coming to these meetups and networking and listening to demos and feeling insecure in the audience that you don't know what the hell's going on, because that's how you get here. At least that's how I got here. All right, so where are we? Talked about the AI Alliance. All right, so here's what you're going to see. We're going to take a GoFannon function, and I submitted this to GoFannon as a function about a week ago. And this is an extremely trivial function, and I did this on purpose to see if we can marshal something through a function pull request all the way through an actual living, breathing agent. So the function is basically, it calls a REST endpoint from a group called OpenNotify, and it just returns the latitude and longitude of the International Space Station, the current latitude and longitude of the International Space Station. That's all it does. There's no authentication, no parameters on this, no posting, nothing. It's a trivial GET that returns a trivial JSON package. And I did this purposely because I wanted to see where I was going to get tripped up in this and how far I can go before we open the GoFannon repository to the masses. All right, we then wrote the AWS Bedrock agent driver for this thing. So again, the experiment here is to take a function defined in GoFannon and deploy it as a Bedrock agent. Now we chose to do that for demonstration purposes using Botto 3. Now everyone knows Botto 3. It's been around a lot longer than some of these other AWS deployment techniques. It's the most familiar. The proper way to do this is probably using CDK, but that hasn't been out as long and it's a little more complicated to use. So what we did is we wrote this in Botto 3 just for demonstrated purposes. I wouldn't do this in production, but we figure that Botto 3 has been around longer. We have more of a chance of people understanding this than if we did it in CDK. All right, so once we deploy it up on Bedrock, and I'll talk you through that in a minute, the agent is then uses Claude. So there's not many foundational models right now up on AWS where it can be servicing agents. So Claude is one of them. And if you go into AWS, it'll tell you in the agent drop-down box what you can actually use. So Claude is one of them. So we're going to use that for the example here. And then in proper cloud discipline, we're going to deploy and destroy all this with a single button push. So you can put this in a CI/CD pipeline. You can do this on a development branch and not stomp on anybody. So all AWS discipline is in effect here. Okay, even though we're only going to demonstrate AWS Bedrock here, GoFannon also supports, as Trevor said, small agents and LangChain's agent framework. Okay, so let's do the demo here real quick. All right, I need 3 hands for this. All right, so what's on the screen right now is the code that we're going to execute. And lines 9 through 18 is the minimum I found to turn a function into an agent. Okay, so there's just a bunch of strings. We have to give it a name, we have to give it a timeout, we have to give it instructions, which basically says, as an agent, you are an expert on the ISS and you're going to return the current position when asked. and the version of Python we're going to use, and just a temporary build directory to build the agent. Okay. Then all we do is we instantiate the class, and we call export to Bedrock. That's it. That should take all. That's all we need to deploy this up on Amazon. And this is on main in the GoFandom repository right now, and I'm on main. So if you want to try this out, it's under, where did I put it? Test integration. And you have to be logged into AWS, obviously, in order to manipulate AWS resources. You need an AWS account. So I'm already logged in on our account, so I'm just going to do Python testbot 03. All right, and this is going to take about maybe 15, 20 seconds to run, and when it's done, the agent will be up there. It's going to pull the function out of the GoFandom repository and deploy it up as a AWS Bedrock agent. And then we'll go in and we'll actually play around with it. We'll use the AWS interface, user interface to play around with it.
Quick question while you're doing this. The repository, is that local or is it always going back to GoFandom?
I do have the repository replicated locally, but we can do a remote git install from the repository.
So you kind of do something that's not local automatically go to the main repository.
Yeah, so this example, I have the GoFandom repository cloned locally, and that's wired into this. But it would be fairly easy to change the test to run, pulling GoFandom from the function from the target repository rather than locally. Okay, so we're deployed. Now let's go over to the user interface. All right, so we should be logged into AWS somewhere here. There we go. And we're just going to shortcut this because it's a little easier to see on the screen. Okay, so if you're not familiar with the agents on, hold off on that. I'm going to walk through what the architecture of this, what we actually deployed, and how it all fits together in a minute. But what I want to just do is do a demonstration on this so you can see this thing live and in action. So if you build an agent correctly, you get a chat window here. So what I'm going to ask it is, can you please tell me the current location of the ISS? Okay, so can you please tell me the current location of the ISS? Now, if this works right, it's going to call the GoFandom function that calls the REST endpoint that gets it, and it should return the current latitude and longitude. All right, now that's an example, but it's a pretty crappy example. Let's do a better one. What would the ISS hit if it currently crashed? Okay, so the question I'm going to ask is, what would the ISS hit if it crashed? Okay, so what on earth would it hit if it crashed? Now, it should know the latitude and longitude, and it should be able to figure out what's underneath it. So let's see. Okay, so it would hit the Atlantic Ocean approximately off the coast of Virginia or Maryland in the United States. So I've done this a million times, and I haven't hit anything yet. It always crashes into the ocean. So if you want to build an agent that says the space station's flying overhead and you better duck, this is good use for this agent. I'm sorry? We'll talk about that in 1 second. All right, so here's how this works. Here's this thing in action. Okay. All right, so if you follow the red numbers, it'll walk you through how this works. So I prompted it, can you please tell me the current location of the ISS? The agent intercepted that. We sent that to the agent. The agent then made a call, the first call of 2 calls it's going to make to the LLM. Okay, and the first call, that number 2 circle, the agent is going to look at all the agents that's registered with it and pick one that is the best candidate for answering this inquiry. Okay, and since we only have 1 registered right now, it's going to use that one. And I'll show you exactly the line of thinking it uses in a minute. All right, so after 2 is done, it's going to know it needs to call the GoFandom function, which is implemented in this case as an AWS Lambda. So very quick compute, less than 15 minutes. All we're doing is to get Python request get call, and it's going to route the request to the Lambda, and I'll show you the Lambda in a minute, what that looks like. And then I think you'll see the power of how this all fits together. The Lambda is going to call the space station information. The space station is going to return the JSON payload in step 5. That's going to return back up to the agent, and the agent's now going to insert that, what it got in the JSON payload, is going to insert that into the prompt to answer the question, what is the current location of the space station? So it made the first call to figure out what function, what agent to call. It called it. The agent returned the JSON payload, which is then fed into the prompt on the second call in circle 7 on the board. Okay, so that's all. There's no magic here. All it's doing is we're calling a function to get the information, and we're going to jam it in the prompt on the second call. What the Bedrock agent is doing is tying this all together for us, so we don't have to do it manually. And you can see the Bedrock wrapper is actually deploying the agent and the Lambda, and the GoFannon function is actually buried in the Lambda, and we'll see that on the next slide. Okay, so here's the Lambda that executes. The GoFannon function is simply the import statement. We're going to import the function, and we're going to import the ISS locator function out of GoFannon. I'm not bringing the whole thing in. We're just bringing in the function we need. And then lines 7 and 8, the red box, the second red box, that's going to make the call. So we've got this abstracted out where we instantiate the class, and then we call tool.function. And then tool springs into action. Now this one's a little oversimplified because it's a get and it's no parameters involved. But we'll see on the next slide how the LLM handled that. And then lines 9 through 16 are how you get this back up to the LLM using the Bedrock framework. Now this was hard code to find. This was ridiculously difficult to find in the AWS documentation, how to get this thing to return properly. I burned a lot of time trying to get that blue box straight. It's basically you're feeding a bunch of stuff coming in from the request. You're just passing it right through the response, but you got to get it right. And line 14 is you're tacking on the response from the ISS call. So you just, whatever it responds, you pass it back up to the LLM. And if the service is down and it responds, we don't know where the space station is, it responds an error, the LLM will take that into account and say, I'm not sure where the space station is at the moment. So if the function gets busted or the service goes down or something happens, the LLM will react accordingly.
In the previous slide, you had a timestamp. Is that UXC pop format?
Correct. Okay, now this is red circle number 2 on the other diagram. This is what we're going to do is we're going to prompt this thing saying where's the space station, and this is the reasoning that the LLM came up with to how it's going to treat this problem. So this is like an explain plan. So it basically says to get the current location of the International Space Station, I will need to call the get for the ISS locator function. This function does not require any parameters, so I can invoke it directly. So the LLM came to the right conclusion based on my prompt to which function it needed to call and how it needed to call it. No parameters needed, so boom. All right, this is one more thing. If you're in AWS and you understand how to deploy things on serverless and at scale, and this is the whole trick to this solution is production quality, it will scale, it's fault tolerant, and it's highly available. So we're all using everything in the architecture here, serverless. We can set this up and it would be production quality. There's basically 4 things we need to talk, we have to get to talk together, that have to talk together here. We need to give the agent rights to use the model. So that is one IAM role with a customer managed policy that says our agent that we created can use the LLM. Then in order to get the agent to be able to invoke the Lambda, we have to tell the Lambda that it can be invoked by the agent. So that's a little backwards, but that's how it works. The Lambda allows to execute by the agent. And then for quality, we have to have the Lambda be able to log everything it's doing to CloudWatch. And we do that with an IAM policy, second IAM role with a AWS managed policy that just says the Lambda is allowed to use the logging. And boom, we've got a production-ready solution right here. Okay, so lessons learned. So I was able to get a function past the brutal review process in GoFannon. I was able to get the code to deploy this on Bedrock past the review committee. I was able to demonstrate that it works. And this raised the question is, where do we draw the line on GoFannon? Is it a function repository? Is it an agent repository? Is it, where do we draw the line? So we kind of worked that out earlier this week. And as Trevor said, it's strictly a function repository. We're going to figure out the rest as we go. And this is all very new and moving very quickly, so this is how things happen. The AWS Bedrock is production quality, and it's very inexpensive. Right now, we're not incurring any charges because it's all implemented in serverless. The only time we get charged anything is when the Lambda is running, and we get charged by the milliseconds that that's running, and we get charged on the number of tokens we hit the LLM with, which is like, hundredths of a cent per million tokens. So this can sit there and just wait for requests, and it will never run up a bill, and it will never, it's all serverless. The default cases for it are pretty low. All right, so next steps, what are we working on next? All right, so obviously we need a more complex function. This was a trivial function. We need something that's got some teeth to it. Then we got to build an actual agent with value. Knowing where the space station is going to crash is one thing, but we've got a couple things on the drawing board here. An agent that you can point to a SQL database and without writing any SQL, be able to develop analytics off it. So SQL-less analytics on a SQL database. We're trying to get funding for this, so we're trying to figure out if we can write an agent to help us seek out grants. And then there's a couple AI Alliance core projects that are out there that show promise that need, their expertise is in different areas, but they may need an agent provider. And we're seeing if we can be the agent provider for some of these other AI projects. Multiple agents are hot right now. Having one agent is good, having 5 agents is better. So be able to push the limit on a number of agents that are involved in a agentic operation. We definitely need to cut over from AWS Spot 03 to AWS CDK, so this is a little tighter in production deployment. And then bring in other agent frameworks, like we said, LangChain, small agents, and OpenAI, that was just released yesterday. And then continue to roadshow it. So we're going to need speakers for next month. If you're interested in taking on one of these, we'll hold your hand, and do the best we can to transfer knowledge, and then you can get up here next time and talk about what you learned doing one of these things, taking this as the next step. And then we don't have to keep fighting for speakers. So if you're interested in doing that, come talk to Trevor or I, and we'll see if we can have another success story come up here next week and explain how we are able to take this to the next level. Okay, any questions? Yeah.
When you ask it where will it crash, is that just assume the coordinated, the coordinates in the atmosphere? It doesn't take into account physics or weather patterns? Right?
No.
So it's straight up.
It's not going to hit us, yes. But yes, that was just a test to see if we asked it a question that involved its location, if it would still.
I mean, real life would be physics, trajectory, weather patterns.
Yes. And it wouldn't crash, right? That's, yes.
How exactly did you write this function? Is there something within GoFannon that is actually transforming it to work with the other agentic frameworks?
All right, so yes, that is the whole, let me pull that back up. Oops, not that one. We want the IDE. Okay, this right here handles the deployment. And it just takes one argument, which is this payload right here. So it's able to take the function, and if we want, we can pull up the function. Give me 1 second. If you want to see what the GoFannon function looks like.
Yeah, that'd be helpful.
Yep. I should have had this ready. All right, so here's the GoFannon repository. We go under, where am I? GoFanon, and here's our list of functions Trevor mentioned earlier. We'll go to Open Notify Space. Okay, so there's no magic here. This is a Python function that all it does is it calls the REST library, uses the REST library to make a call to, where is it? Right here. Line 85. Everything else in this file is error checking to make sure that if the service breaks, I can communicate up to the LLM that the service is broken. So if you look at this, where is the error message? I got it in here somewhere. All right, the ISS endpoint returned an error. No location for the ISS can be determined. So it either returns the proper message from the proper JSON payload from the service, or it returns this. And any one of the 600 ways this thing can blow up.
And there's some kind of method that's transforming it in a way that's usable by Modo 3 or small agents.
Yeah, so right here, this is the template we would use for any function in GoFanon is right here. Okay, so once you define that and you call the export to Bedrock, everything should happen. All right, the mix-in, you're so proud of the mix-ins. Let's do the mix-in. I would never have done a mix-in, but that's me. Yeah, where am I? Base. All right. All right, so this is actually when you call export to Bedrock, this is the code that gets called. All right, and it's just like I said, Bot03 code. Create the Lambda, create the agent, create the IAM roles, create the policies, attach the policy to the roles, and turn the agent on, and that's pretty much it. Okay, we'll see how far we can push this, but it's only about, maybe, what, about 600 lines of code, maybe? Yeah, 700 lines of code.
So it's like we are calling some API that's written the latitude and longitude, and we pass that data with the user prompt and our own prompt to LLM agent, and LLM agent is written. So the entire thing is like using a simple code we can
Yeah,
write
that's-
a simple thing.
That you know the secret. Now, there's no magic to this. Everyone knows all you can do is set the prompt, and that's all you're doing here is we're seeding the second call, this number 7 here. We're seeding it with the lat long from 5, and we got that from the first call, number 2.
Entire architecture we are this library make it simple.
Yes. It's not that complicated to begin with once you understand it. And that's how, when you sit down and we got to give a presentation on this in a week, you better figure this out quick. That's what happens. Yes?
AWS Lambda has some storage first, right? 512 megabytes.
That's correct.
Yeah, so why AWS Lambda? Because let's say, for example, a lot of people start using GoFundMe. Wouldn't that affect its...
No, everyone would have their own Lambda. You'd have your own agent. Every agent has its own Lambda. It's created part of the deployment process. And, oh yes, if everybody was using GoFanon, wouldn't the Lambda get overloaded? The Lambda's got limits on it. But the point is everybody creates their own agents with the library on your own AWS account with your own resources, and you create your own Lambdas. So last step of this is I'll tear everything down and walk away, and the account will be in the same state it was when I started.
Okay, it's more like a service. It's not like a software.
Yes, it's for you to deploy your agents the way you want them to deploy. We'll give you the functions, we'll give you Google, we'll give you ISS, we'll give you whatever, and anyone can contribute stuff that someone else can use. We're trying to get ServiceNow, because they've got a very complicated API, to be able to allow us to build agents on their platform. But sky's the limit here. Yes?
So for what I understand, you just call the agent once the base LLM model does not know the answer, right?
Correct.
And then how do you know that the LLMs don't know that, and that, I don't know, maybe in the future, maybe they will get a cutoff date you write are gonna be no longer useful.
All right, so that's part of the description part that Trevor was talking about, right? We have to register. It was invisible to us because I did it in the background. Okay, I'm sorry. The function, how does the LLM know to use the function, and what happens if the function changes? If that's, okay. The step that was invisible here that you didn't see, it runs in the background, is the function gets registered with the LLM. That's part of the description step that Trevor was talking about. So when inference comes in to the model, it can then say, do I know the answer to this question, or do I have to use a function? Okay?
But how do you know, like, the functions that you're gonna write, like, the models that are coming out are not gonna know them? Say, like, we're gonna write 100 different functions, and these are, like, how do you, like, make, I don't know, the business case for this?
I created a function because I wanted to know where the space station was, and I deployed it. All right, that doesn't help anyone that wants to know, anything else. So what you would do, write a function, deploy an agent, and again, there's no cost for deploying an agent unless it's being used. So you can deploy any number of agents out there and sit back and watch and see how they're used. Okay, but you're going to have to know the business case. That's why Google is a great agent, because it's a general purpose search, right? What Trevor demonstrated, right? This is more specialized, but you wouldn't normally get the location of the space station unless by a Google search, unless Google used its LLM to answer your question. So the other way to look at this is a way to interact with APIs without having to code. Somebody else can code it up for you, and then you can use natural language to query the API. Where's the space station? I don't have to write the Python to do that. I can have someone else can write the Python, deploy it, and then I can ask the LLM in natural language that question, and it'll answer that. So think of any API out there that you don't want to interact with programmatically. You want to interact with it using natural language. And this would be an example of how you could do that. That's correct. All right, so the question is, some agents may require a vector search, yes. And we can do a big philosophical discussion. Is that RAG? Is that agentic? Is RAG a special case of agentic? Is search any search? The API that we did was not a search. It was, I want to know something, it gave it back. It didn't have to figure out, query a bunch of services and do it. I didn't have to search for a document to answer this. So again, things are changing rapidly, and it's going to be whoever can argue, has got the, can argue the best is going to probably have the high ground on this. But you're right, some agents are vector searches. So our architecture would be a little different, and we do have a RAG demo, but that would be, if someone in here is built any kind of RAG application, which was, all right, maybe you want to talk about that next time and explain what what RAG is versus what agents are, and we can hash that out. That'd be a great demo. Yes?
So going forward, currently this example you've shown has a function that's utilized for finding the position of the ISS. Is the general idea for this project more so allowing users for integration with their own specific functions, or would it be more so like a kind of suite of functions that are kind of already provided within the library that users are kind of expected to use, then maybe just slightly tailored to whatever their specific application is?
Right, so what's the intent of this? We have functions up there as intent to use the functions, write functions. So the whole idea came out with, we go to Hugging Face to get models, we go to Hugging Face to get data, okay? There was no function repository. So the lightning bolt was, what if we have a function repository where people can write functions, and then we can create agents on top of those functions? That was the thinking. Now, whether or not we get there or not is another story, but that was the thinking a couple weeks ago. Yes, Ron.
So I'm trying to understand what functionality GoFanon itself is providing, right? So you have a way of deployment to, say, Bedrock.
Yes.
So you have a Lambda function deployment.
Yep.
You have some Python code which is actually getting wrapped around
Yep.
in some Lambda function to be deployed. You don't have to worry about the APIs. It just gets deployed through this
Yes.
library, right?
Yes.
And it also calls some LLM behind the scenes. So can we change that LLM? Do we have
Yes.
control over that?
Yeah, that was actually one of the arguments on the deployment on line 15. We pass in the model we want to use here.
Okay, and those models have to be available on the platform that you're deploying to.
They are, and these are standard models that are always available on AWS, that the AWS provides, and they bill you for your use on those models.
Yeah, well, what if I want to use some model from, say, Hugging Face? So can I access Hugging Face?
Good luck. You're going to have to figure out how to get it out there. You're going to have to pay an enormous bill. And you have to make sure it supports agents. So the shortcut here is to use what they want you to use. And if you want to get creative on this, you can certainly get creative on this, but you're going to lose the audience.
Also, whatever I build, right? So
Yes.
I can definitely use whatever agent I want running at Hugging Face or locally or wherever I want it, and then I can deploy it wherever I want.
Right. And
Yeah.
it's part of the agentic community here. There's, like Trevor said, there's the pure researchers that are doing pure research. There's guys that are collaborating on standards, and then there's the value creators. So this talk is all the way at the end of value creation, where we don't care about any of this stuff. What we want to do is get something out there that we can demonstrate and drive value from. So the optimization, the evaluation, all that stuff, we skipped all that and just went straight to the end to try to prove that we've got something that's got some value here.
Instead of a serverless architecture, can we use a compute-based architecture in order to implement any Hugging Face model that we want to? So it gives a bit more customization to a user.
Yeah, that's going to take more engineering work, because we're like, this was the shortest way to deploy something for demonstration purposes, to use what was available. Anyone who wants to, yank out the Claude model and use another model, Llama is not even, I don't think it's I have to look and see. Pick out a model and try to get this demonstration to run on a non-public model. Absolutely. Yes. How old is GoFanon? A week? All right, a month. Yes. Yeah, that's going to be a much higher engineering complexity problem, is to get workflows. And that's one of the, let's go back here. All right, this AI Alliance Core project here, that's exactly what he's trying to do, is automate human workflows automatically with agents. So he may need an agent provider, and we need to see if we can work with him, instead of inventing his own agent framework or whatever, if we can work with him to try to get these things to work together. That's what the AI Alliance is all about, people working on individual problems and trying to connect up to solve bigger problems. Yes, the model, the question is, the agent part of this that works is the LLM has to support it. Yes, that is correct. There's only, if you go into Amazon's supported foundation models that they have out there running right now that you can connect to and do inference on, there's only a few of them that support agentic operations. Right, now remember, the foundation model, the input into a foundation model is a prompt, right? That's really all we have to work with unless we start re-architecting things. So all this is doing, all this agent stuff is doing, is seeding the prompt with the right answer so the LLM can easily access it. And that's really the secret sauce here, is there's nothing complex going on here. We just ask the function to give me the space station, we tell the LLM where the space station is, and the space station can then answer the LLM can then answer our question. Okay. Well, thank you very much.